Welcome to this lesson on understanding the costs of quality. In this lesson, you will learn how to recognize and quantify quality costs, and how to begin containing the costs of quality. So, let's get started. Perhaps the main reason for quality initiatives is to reduce costs. In the quality context, we consider these as the costs of quality. In this unit, we will examine the costs of poor quality, the concept of zero defects, and the costs of quality in your organization. When we think of the costs of quality, we normally think of costs associated with poor quality. The Price of Nonconformance, by Philip Crosby, or The Cost of Poor Quality, by Joseph Uran, refers to the costs associated with providing poor quality product or service. However, the costs of poor quality is only one side of the story. The costs of quality actually comprises of 4 elements. External failure cost. The cost associated with defects found after the customer receives the product or service. For example, processing customer complaints, customer returns, warranty claims, product recalls. Internal failure cost. The cost associated with defects found before the customer receives the product or service. For example, scrap, rework, re-inspection, retesting, material review, material downgrades. Appraisal, or inspection cost. This is the cost incurred to determine the degree of conformance to quality requirements. That is, measuring, evaluating or auditing. For example, inspection, testing, process or service audits, calibration of measuring and test equipment. And finally, prevention cost. The cost incurred to prevent poor quality. For example, due product review, quality planning, supplier surveys, process reviews, quality improvement teams, education and training. We can see the costs of quality in this illustration. External failure costs are costs that are caused by deficiencies found after delivery of products and services to external customers, which lead to customer dissatisfaction. Examples include the cost for complaints, repairing goods and redoing services, warranties, customers' badwill, losses due to sales reductions, and environmental costs. Examples of internal failure costs include the cost for rework, delays, redesigning, shortages, failure analysis, retesting, downgrading, downtime, and lack of flexibility and adaptability. Appraisal costs are costs that occur because of the need to control products and services to ensure a high quality level in all stages, conformance to quality standards and performance requirements. Examples include the cost for checking and testing purchased goods and services, in-process and final inspection or testing, field testing, product, process or service audits, and calibration of measuring and test equipment. The total quality costs are then the sum of these costs. They represent the difference between the actual cost of a product or service and the potential reduced cost given no substandard service or no defective products. Prevention costs are costs of all activities that are designed to prevent poor quality from arising in products or services. Examples include the cost for quality planning, supplier evaluation, due product review, error proofing, capability evaluations, quality improvement team meetings, quality improvement projects and quality education and training. Typically, for any business, the costs of internal failure due to poor systems, processes, waste and other production problems form the greatest percentage of total costs of quality. External failure costs are next, accounting for typically around 25% of the overall costs of quality. Interestingly, the costs of prevention and appraisal account for about 25% of the total costs of quality between them. The fact is that the more time and investment we put into prevention and appraisal, the less costs of poor quality we are likely to incur. The quality cost pyramid helps illustrate this rule of quality cost escalation. The rule explains how failure to take notice of one cost escalates the loss in terms of dollars. Of the 4 types of quality costs, prevention cost should probably take priority, because it is much less costly to prevent a defect than to correct one. In this illustration, we attempt to show that $1 spent on prevention will save $10 on correction and $100 on failure costs. As one moves along the streams of events, from design to delivery, the cost of errors escalates as failure costs become greater. The quality cost curve is used to illustrate the inverse relationship between the costs of good quality and the costs of poor quality. There is an inverse relationship between prevention and appraisal effort and failure cost. The optimum conformance to quality, or defect level, is where the increasing costs of the prevention and appraisal curve converges with the curve of decreasing failure costs. Total quality costs are minimized, to the point where the cost of prevention plus appraisal equals the cost of failure. Another factor to take into account in analyzing the costs of quality is that many of the costs go unseen in the first analysis. The obvious and visible costs are a small portion of the overall COPQ. The bottom of the iceberg represents the majority of the COPQ, and are not as easily identified and quantified. So, where do we look to start quantifying the costs of quality? The diagram below gives you some ideas about where to look in each quality cost category. One of the most influential ideas about the reduction of the costs of poor quality was the notion of zero defects. This phrase was coined by Philip Crosby in his 1979 book titled, Quality is Free. Zero defects is a way of thinking and doing that reinforces the notion that defects are not acceptable, and that everyone should do things right the first time. The idea here is that with a philosophy of zero defects, you can increase profits both by eliminating the cost of failure and increasing revenues through increased customer satisfaction. Zero defects is referred to as a philosophy, a mentality, or a movement. It's not a program, nor does it have distinct steps to follow or rules to abide by. This is perhaps why zero defects can be so effective, because it means it's adaptable to any situation, business, profession, or industry. Zero defects is not about being perfect. Zero defects is about changing your perspective. It does this by demanding that you recognize the high cost of quality issues, continuously think of the places where flaws may be introduced, and work proactively to address the flaws in your systems and processes, which allow defects to occur. Zero defects is a standard. It is a measure against which any system, process, action, or outcome can be analyzed. When zero defects is the goal, every aspect of the business is subject to scrutiny, in terms of whether it measures up. There are no step-by-step instructions for achieving zero defects, and there is no magic combination of elements that will result in them. There are, however, some guidelines and techniques to use when you decide you are ready to embrace the zero defects concept. Management must commit to zero defects. Zero defects requires a top-down approach. The best-intentioned employees cannot provide zero defects if they are not given the tools to do so. When you decide that zero defects is the approach you want to take, recognize that it likely represents a significant change to the way people do things. Manage the introduction using the principles of change management. To learn more about zero defects, download the article in the references. Zero defects requires that you understand what your customers expect in terms of quality. Design systems that support zero defects where it matters, but don't over-design if the end user just doesn't care. Adopt a proactive approach. If you wait for flaws to emerge, you are too late. Create quality improvement teams. Zero defects must be integrated with the corporate culture. Zero defects needs to be accepted as the way things are done around here. Poka-yoke is a Japanese term that means mistake proofing. Poka-yoke was invented in the 1960s by Shigeo Shingo of Japan. Its purpose is to eliminate product defects by preventing, correcting, or drawing attention to human errors as they occur. It's an approach that emphasizes designing systems that make defects almost impossible or, if they can't be avoided, easy to detect and address. To implement zero defects, you have to have strong systems like Pokayoki in place. Here are some tips to help get started with zero defects. Monitor your progress. Build mechanisms into your systems and methods of operating that provide continuous feedback. This allows you to act quickly when flaws do occur. Measure your quality efforts. It is important to express your progress in terms of the bottom line. Take baseline measurements, so you understand the cost of defects in your organization, and can measure the benefits you're achieving in eliminating them. Build quality into your performance expectations. Encourage members of your team to think about how they can achieve zero defects, and reward them when they're successful. Recognize that although zero defects is a destination, circumstances keep changing. And monitor, evaluate, and adapt in a continuous, never-ending cycle. Now, here are some basic guidelines to quantify the costs of quality in your organization. First, define the products, process or processes being measured. Next, identify components of 4 measurement areas. Internal, external, preventative or assessment costs of quality may be used to compile a total cost of quality. Next, identify the costs which directly affect the selected scopes. Measures can be divided into 2 basic areas. Direct costs, which affect actual profits, and indirect costs which only indirectly affect profits. Indirect costs are those associated with productivity, and typically do not directly affect the accounting of an organization. List all the measures to be captured. Once a list of potential costs resulting from poor process or product quality are defined, the data should be gathered. Finally, compile the measurements to provide a cost of quality metric. The cost of quality metric may become a valuable tool by which an organization gauges process or product quality control. So, to summarize, just why then do we need to understand the costs of quality? Here are some good reasons why it is important to understand the costs of quality. Net profits for many companies is less than 5% of sales. The COPQ on the average is 17% of sales. The total COQ on the average is 25% of sales. The COPQ in some companies is as high as 40% of sales. And finally, the COPQ is typically 3 to 6 times as large as profits. Let's close the an overview of the key points of this unit. There are 4 types of costs of quality. These include internal failure costs, external failure costs, appraisal costs, and prevention costs. The reality is that a company normally needs to increase the spend on the price of quality before the costs of poor quality can go down. In addition, spending more on prevention will reduce appraisal and failure costs over time. Organizations need to understand the cost drivers and work to reduce the costs of poor quality. It is argued in TQM that this focus on cost drivers will enable an organization to improve productivity with reduced costs, and thereby deliver improved profitability.
There are a number of activities to complete for this unit. Take the time to complete these in your manual. In this way, you will better learn from and retain the knowledge covered in this unit.
Thank you for watching this lesson. We hope you have found it useful. Visit our website to view our range of courses on operations and quality management.